Welcome back, everyone. Let's take a look at how we're going to examine this data. We've looked at this already, and we found that if we put it on a standard graph like this one on the right, we did not get a straight line, far from it on a straight line. But when we put it on log-log paper, it did turn into a straight line. So we want to see what it is that means. And we're also going to examine semi-log when it comes down to this. So we've got two variables. We have the independent variable, and that's going to be the x in our function. And then we have the dependent variable, and that's going to be the y in our function. So if y equals mx plus b, then the function would be a straight line in a standard x and y plot. Well, clearly our data is not that. So it must be something else. So another really common function, and one that I look at when I see this curve, I kind of think exponential. So maybe y equals a times e to the k x, where a and k are just some constants. Don't know what they are, but they're some constants. Well, if I take the log of the right-hand side, and just the right-hand side, then I'm going to get y equals the log of a e to the kx. But if I use my logarithm properties, this is going to be the log of a plus the log of e to the kx. But that's going to equal the log of a. Now the log of a is a constant, so the log of a is just another constant, plus kx, because remember the exponent in a logarithm comes out front, times the log of e. But I can rewrite this as the log of a plus k, the log of e, times x. But k is a constant, the log of e is a constant, probably 1 if it's a natural logarithm I did on both sides. And so this is equal to some constant, which I'm going to call b, plus another constant, which I'm going to call m, times x. So this is, and actually let me use a lowercase b here, this is a straight line. This is y equals mx plus b. So if I take the logarithm of only the right-hand side, only the side with the independent variable, only the side with the independent variable, then I'm going to get a straight line. And that's what semi-log paper does. Okay, it takes the logarithm of y. Now you might look at that and say, wait a minute, you took the log of the right-hand side. And that's a true statement. But remember that the dependent variable y equals ae to the kx, and I took the logarithm of ae to the kx. I didn't take the log of x. I took the log of ae to the kx, and that's y. So I actually took the log of y. I took the log of y, not the log of x. And when you look at semi-log paper, you'll see the y-axis is the one that has the logarithmic scale. The x-axis was straight. Of course, you can do it the other way, but in that case, your function would be y equals a log kx, and then you would get a straight line. But in that case, this would be the logarithmic side, and this would be the uniform side. All right, but we're not going to tackle that right now. All right, so we know from our previous experience, but we know from this graph that when I did the logarithm along the y-axis and then uniform along the x-axis, I did not get a straight line. In fact, I got a straight line when I did the logarithm along the x and the logarithm along the y. When log paper gives me a straight line, then we're working with what's referred to as a power function. And in this case, the function looks like y equals a x to some exponent n. And I don't know what n is. And it's generally not a nice function or a nice number. I mean, if it's a cube, like a 3 or a 5, then it's a simple polynomial. But it's usually going to be something a little more unusual than just a polynomial. So how do I make this look like a straight line? So what I need to do, keep in mind this is log paper, right? So I'm going to take the log of y equals the log of ax to the n. And when I do that, I get the log of y equals the log of a plus the log of x to the n. But that's equal to the log of a plus n times the log of x. And over here I got the log of y. So let's replace the log of y with y. I'll just use a capital there. And then a, I'm just going to call that the letter b. It's a constant. Log of a is a constant, so the log of a is a constant. Plus n, and then the log of x will be my other variable. And so I've got a straight line. Y equals nx plus b. In this case, n is the slope of that straight line, but it's also the exponent in the n power. And so this is linear. This is going to be linear. So if I put it on log paper, then what I've got is a power function of this nature. It's just that n isn't a nice integer. It's going to be something unusual. Probably not even something simple like 1/2, right? That would just be a square root, but it's going to be really unusual. And so when we did this graph, we got a straight line on my log paper. And so I know this is a power fit. All right, so we'll let Excel do some of that, and then we'll see what we can come up with for data that might not fit any of those functions. All right, if you have any questions on what we've talked about thus far, please do leave them in the comments below. Thank you.